Okay, hello everyone. I'm Joe. I'm from Mooncake Labs, and today I'm going to talk about HTAP was wrong, crack it with Iceberg. So I guess now is actually a perfect time talking about HTAP, since just recently Databricks acquired Nia, which is an analytics company acquiring the state-of-the-art OLTP company. So there must be some connection. So a little bit about myself. Before Mooncake Labs, I actually spent a decade building MapSQL single store. It's like one of the state-of-the-art HTAP systems, which is like probably the only system that runs on single copy of table with both in-memory row store and on-disk column store, which supports like fast scan, SIX, filter, all kinds of aggregations. Essentially, a single store that can handle both transaction and analytics. But it actually takes me the whole 10 years to realize HTAP is all wrong. Okay, this is what I thought things would be planned out. Let's go a little bit back into the history. Like from the 1980s, when people started to work on databases, there's actually no difference between OLTP or OLAP. People have those like expensive like Oracle DB2 machines on like those expensive hardwares. It handles any kind of data problem. Later, like as it advances more, people realize like for analytics use cases, if you put data into like a columnar format, it will actually perform a lot better. So there's like a specialized analytics systems coming like Vertica, and then at the same time, like if you just want to do like OLTP, you want a system with simple row store with the better transaction management. That will be the systems like MySQL. And actually, the diverge becomes even bigger as like both systems need to scale. In the early like 2000s, people like, when started scaling the OLTP workload, they actually started with no SQL. Like that even gives up on the SQL semantics. And then on the OLAP side, when people start to really want to scale the compute, they go to Hadoop, which also like kind of gives up the SQL command, or the SQL semantics, or the consistency. So seems like the two systems are just diverging more and more. However, in the 2010s, things are coming back a little bit. For the new SQL systems, essentially they're trying to say like, you don't need a NoSQL. You can actually, we can have distributed SQL databases that have all the like old SQL semantics. And also for the analytics side, people started building the cloud data warehouses. Again, like instead of just having like files on Hadoop, files like on file systems and then querying them, people saying like, I actually want the full SQL semantic to do the query. And I actually like also want some kind of like database consistency guarantees. So maybe I say like, although like those two like look very different from outsider, internally they're actually not too different. So most of them are using MPP architecture. Most of them, like all of them, have like SQL interfaces. This is kind of like why what I was trying to build before is like, why can't we just combine them? Seems like it's already a very similar architecture. If we just have the row store and column store stored together, have both execution engines mixed up, we can have like again a single kind of storage or single kind of database that handles both, as good as the old like vanilla days. Well, turned out this is something like not me saying it. It's like Andy Palo in one of his talks saying like new SQL after 10 years is that. And the reality is like HTAP never took off. There are like many different reasons, both like technical wise and also like non-technical wise. But here's like some of my summary. I think the biggest one is like it's really hard to replace any OLTP system. So if you want to build one magical system that handles people's OLTP and OLAP, you need to replace their old OLTP system. Otherwise, like there's no room for the new system. But like OLTP is actually running like people's most critical workloads, and like if there's a way to work around it, no one will replace it. No one will get promoted if you replace the OLTP system, but someone will lose his job if there's something goes wrong. And also, like one thing people start to realize is like there's actually not much OLTP workload needs distributed. Not like the true, especially not the true distributed. It's like even for the biggest organizations right now, like OpenAI, they are running on like unsharded Postgres, or they are like metadata or some of the user information. Like it's fine to just have like read replica or have like readable replica. That will serve most of the OLTP use cases. And also for the cloud native side, databases should be like shared, nothing shared, should be shared disk, where all the like new SQL systems or the real-time analytics systems are more building around shared nothing with local disk. And also, probably this a non-technical reason is OLTP and OLAP are owned usually by different teams. So when you're trying to sell an HTAP system, there's no team to sell for. So this is the reality that happened. On the OLTP side, people just, as like the systems evolving, the hardware's evolving, people realize like an open source Postgres can actually handle most of the OLTP cases. And again, on the OLAP side, we're seeing like data lakes, lake houses like Iceberg is winning. Oh, this is actually creating a very interesting diagram or very interesting new opportunity. It's like instead of people just database developers building databases, with all this like composable data part of the data stack, every data team is at the end trying to constructing a database, something like a database internally. And this database have like some OLTP components and some OLAP components, and they want to like work great with each other. This is essentially every data team is trying to build an HTAP database. So what can we learn from the actual HTAP databases? This is kind of one question I had when I started Mooncake, or when I started like getting into the lakehouse world from the real-time database world. But something like feels mystery to me. It's like, well, there are HTAP systems that support like consistent replication to a console. This is like TiDB. Like for TiDB, like they have a different kind of nodes. One is the TiKitty node, which is for like OLTP, and then the TiFlash node is a modified version of ClickHouse. But they actually like replicate between them almost like consistently, and you can query them like with up-to-date data. Well, for Iceberg, you usually have like minute latency with staging tables or causing a ton of small files. And this is something like Ryan Blue said himself, like don't use upsert from Blink. It will destroy your table with too many deletion files. So something must be wrong here. People may think like CDC or replication is the issue. But in reality, like the CDC tool replication tool is never an issue whenever you want to replicate from a database to another database. It's always the destination that's the issue. Iceberg is not designed to be that kind of destination. So you actually, what you want is not a better CDC tool, it's a real-time column store, hopefully on top of Iceberg. Okay. So that might be the first question. It's like most of the systems supporting real-time writes LSM-based solutions like ClickHouse or Apache Palo. Essentially, how that works is like instead of whenever you update a row or delete a row, instead of like directly updating it or deleting it, you insert them into an LSM tree. So upon read, you will actually, since the LSM tree gives you a way to read the table in a sorted order, you will actually merge them and then pick which version to read at read time. And there will be like a background merger, merging all the versions of different row, of row with the same primary key in the background. Well, people thought this is the perfect solution for this kind of streaming updates. The reality is, this is actually not a solution. This is the workaround people find with this kind of systems. Because like whenever you doing upserts or replace merge tree on an LSM tree, The sort order is used to maintain the primary key instead of just used to sort the data table. So instead, like you picking the clustering, you picking the sorting, your primary key becomes some random primary ID that's useless for your query. That's kind of one reason like why Iceberg performs much better than a lot of the other like streaming lakehouses. And actually, like looking at Iceberg can actually do it, especially with Iceberg version 3. Iceberg version 3 introduced a deletion vector. So if you know, like for example, you want to delete a row, or you want to update a row, all you need is to like mark one bit as deleted. And for updates, it's like marking the row as deleted and then including the row at the end. This is extremely lightweight. However, like there's one issue is that you cannot find a ratio to delete in most cases. That's what we wish is like, if we can have a primary key on Iceberg, that will make all the CDC or replication from relational databases easier to solve problem. Cool. Now we solve the streaming index problem. What else like differentiates Iceberg from a normal like real-time or like more performance console? There's still like a couple final pieces. First, like Iceberg right now is building upon Apache. Apache, although it's not great for all the batch analytics, it has some like drawbacks especially around like point rates. So even if you have an index you want to read one row, it will still like take at least like the same amount of time as you would be scanning a whole row. Fortunately, like this is also something the community is trying to fix with all the more stickable console formats like Lens or Vortex. I hope this will be also fixed. The other part is like, unlike a traditional database, Iceberg does not have like native index support. So imagine like for databases you want to do a full text search. Now there's vector search or even like just key value lookups. Iceberg cannot do it right now. So if we can introduce indexes to Iceberg, that will complete the story. So yeah, now that's part of what I'm doing or what Mooncake is trying to do. Mooncake is trying to turn Iceberg into a real-time console. Okay, how that works. This is like more for the write path. Essentially, Mooncake want to build an operational layer on top of Iceberg. What it does is like we have maintaining like the indexes ourselves and in-memory arrow batches as buffers. So it will take like any streaming from CDC, and then also this can be served for union read between this in-memory buffer and the underneath Iceberg table. So you can actually query the up-to-date version of the table. And periodically, we want to like flush the data actually into Iceberg format from the in-memory arrow format. Things like Apache is coming from arrow anyway. This is like super lightweight. And this is how it works under the hood. Like we will have row inserts, and then it first comes into the Mooncake, which is the in-memory on this buffer on NVMe. We will be turning those row inserts into arrow batches. And then for the row deletions, we will actually use the index to find the row to delete and then turn them into position deletion log. And periodically, we will flash these arrow batches into like actual packet batches, and also we will flash this positional deletion log into a deletion vector in Iceberg v3. And also the indexes should be flashed from an in-memory or NVMe format to an object store native format. Mooncake wants to be the real-time data layer for Iceberg. Essentially, you can have your Postgres or your logs directly ingest into Mooncake, and then it will write an Iceberg table underneath. And the same table is like also available for union read from other engines like Starrocks or DuckDB. Especially Mooncake will support like fast write or fast read with caching and indexing. It's a single Rust binary, it's stateless, elastic, scaling. It can scale anywhere, and it's also can embed into anywhere, including we actually have a way to embed it into Postgres and turn Postgres into HTAP database. Yeah. So that would be the takeaways. Like HTAP might be that, but let the spirit lives on. It's like the purpose-built, state-of-the-art OLTP systems and the purpose-built, state-of-the-art OLAP system, Iceberg. If we can connect them, make them work seamlessly together, probably with the Mooncake side, we can get the best of both worlds and create the best HTAP system. Real-time workload coming to Iceberg. Feel free to follow us on mooncake.app or send us an email. Questions?
So have you followed CedarDB because they're trying to build another HTAP? Have you followed CedarDB because the German guys is building a new HTAP system again?
Oh yeah. I love their work. I've been following their like research work for years. I think like it's possible, but it's possible. Also, like we prove that in single source. Like you can build one system that can run both like state-of-the-art TBCH and also TBCC on the same system, but no one cares. So hopefully they will find a solution for it, but like I think it will be successful, at least academia-wise or like as a system-wise. Whether there will be a good product, I don't know.
Yeah. Hi. So I wonder, are you aware, like in your presentation, right? So you say for OLTP stands for Postgres,
yeah.
For OLAP is for Iceberg, right? So is that there's another company that built this bridge. Yeah, I've heard like months ago. So Crunch Data also it creates Iceberg table directly in Postgres. I wonder what's your opinion?
Oh yeah,
because it said the injection part, right?
Yep. So when we started this company, we actually built one version of very similar to Crunch Bridge. It's like we actually just embedded Iceberg Delta Lake inside Postgres. But that's actually not what people want. Like just having a data warehousing in your Postgres don't really like make too much sense. It's like you can have that same data warehouse as in Snowflake, in ClayHouse, everything like is more performant. What people want is like they have some data in Postgres that keeps changing, and then they want to run analysis queries on those data. That's the use case that makes sense to run inside their Postgres. And so far, like we are the only one that try to solve that problem, because you actually need a live sync between your Postgres table into your Iceberg table. So it's like it's not enough to just embed Iceberg there.
But don't you think that's a good idea also? One Postgres protocol alone.
I think Postgres protocol by itself is useful. It's like a good user experience. But what I'm saying is like what people actually want is like a way to get your Postgres data into Iceberg format so it's queryable. And that's what we are doing.
Okay, since you mentioned that in the beginning, what's your take on Databricks acquiring Neon? What are they trying to do?
Disclaimer, we're actually working with Neon before, and I actually know Nikita very well. He was my previous manager. So yeah, I think it's an interesting movement. It's definitely aligns with like our vision. It's especially for the newer workloads, you actually need an OLTP system, and ideally you need that OLTP system to talk to your OLAP system and feed into the whole lake house architecture. And I think Databricks is showing the same vision as like what I'm seeing.
Hi, question. So I like talk in general, but there's there's one comment that you said new SQL is dead. I actually don't agree with that. One example is better, right? I think it's probably at least widely used inside Google. And another reason I'm saying this is because actually in my job, I do have real use cases that I think a distributed global scale database should be useful. But it's the price that scare people away. Probably, I don't want to pay that high. Maybe just a bunch of MySQL or Postgres database can also serve a good workaround. It's not that it's dead, but maybe the price is king.
Yeah, like this is not some claim from me. This is something from Palo, like a famous database provider. Yeah, essentially, like most people don't realize like distributed comes with a price. So if you can avoid distributed, like people would actually avoid it. And for most cases, people can. Yeah, I think like later people give up, at least give up the name NewSQL. People are starting saying like distributed SQL directly. I think that has a little bit more success so far. And also, I think TinyDB is doing good recently. So maybe NewSQL is not entirely that.
So it's not entirely dead, right? Is it like that or not?
I think 90% don't really use NewSQL.
Essentially, people don't really need it. But it's like all of them are still like good technology.
Yes, yeah. So on your slides, you say the Apache payments LSM style compaction is not the right way. So how does Mooncake fix it? And also, what's your opinion about the hoodie? Because it's also real time and updates, right? And
good question. Yeah, I think like if you check ClickHouse and see like how they do like handle updates and delays, you'll see like it actually does not apply directly, and then you actually really like duplicate rows when you query the table. That's kind of like the drawback if you need like LSM based solution, and also like your primary key becomes your sort key, which like makes the whole table less effective. In our this is like the single source solution and also like our Mooncake solution. So you actually build a secondary key as primary key that maps a primary key into location. So then you want immediately, like if you get a row, you want to delete the row, you use that index to find the exact location and update, either write a position deletion log or you directly update the deletion vector. So this is in general a lot more efficient than doing LSM and doing merge, since this will not destroy your read.
and how about hoodie?
Yeah, like, I think Hoodie's using something like more or less similar. It's like you write all the logs to the end and then merge them back if you need to do it. So to some extent, like you'll get a similar issue as like Iceberg version 2 position, equality to this. And like you push all the work to the readers. So you can write whatever you want, and then readers will pay like essentially you blame readers. Say like I give you a table, read it.
Any other questions?
Yes.
So when you are writing the Iceberg, do you also make all the compaction, maintenance, and everything? So can we also use those Iceberg tables out of Mooncake too? So I mean, use it as a writer.
So we kind of need to do it since like I kind of believe like as a writer you need to do the compaction, you need to do like a lot of optimizations in order to make the table in a better state. And also like there's actually no good like compaction services out there. And it's like as a Rust-based like serverless system, we can do really a much better job than the services out there.
So if my Postgres has secondary or third indexes, so does it means like in mooncake infrastructure. The secondary author just can propagate to the iceberg as well, and then in the parent time can use these indexes.
In theory, yes, and this is actually something we want to do later. But right now, just for writing, you don't need them. You just only need one parameter index to do like CDC. But yeah, the same architecture can also support secondary indexes and to support like speeding up lookups. But again, like Parquet is not the bottleneck, so it's like it's not. It probably won't be what you expect the performance to be. It's like better than just do a full scan, but it's not like millisecond or sub-millisecond.
Thanks.